Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over how to find probabilities from z-score that's given to you. So, getting right into the example 1, we have that we need to find the probability that z is less than 1.25. Okay, so remember with z-scores that's dealing with a normal curve, right? So if we have a normal curve here, and we've got the mean at 0, and we have 1 and 2. Our z-score that we've got given here, 1.25, lies about right here. So in order to find the probability that z is less than this, we're really going to be figuring out what the area below the normal curve is behind that z-score. So we want this entire area behind z equals 1.25 for our answer here. Now, in order to do that, we can use the z tables because these tell us the area to the left of that z-score. So if we take this 1.25 and find it on this bottom table here, because these are the positive values, we have 1.2, and then we go all the way over to 0.05. So here is our 1.25, this 0.8944 thing. So this means that this entire area that I have shaded in here is equal to 0.8944, which is also our probability. So here, we just got to make sure that if we're looking at a z is less than any number, we're just going to pick it from the table and move on, since the table tells us the area to the left or the area that's less than that z-score that we were given. So now example 2, we have the probability that z is greater than 0.22. So let's just sketch that out on the normal curve here. So we've got our mean at 0, and we'll call that 1. So a z-score of 0.22 shows up right about here. But remember that we're dealing with z is greater than 0.22. So we want this area to the right. Now, in order to get this area to the right, we can't exactly just pick it from the table like we did last time, because remember, these tables tell us the area to the left of that z-score. So if we went into the table and found 0.22, that would only tell us this area. Now remember, the entire area under the entire normal curve is equal to 1. So if we want to find just this chunk that's left right here, we can take 1, oops, here, let me just declutter that. We'll take 1 and subtract whatever this chunk of area is, and that'll give us this shaded region right here. So first, let's go and find the 0.22 on the table. So we've got 0.2, and then we go to 0.02. So here's our 0.22 at 0.5871. So remember, we're going to subtract that from 1 to get the area to the right. 5871, which should be 0.4129. So this is the area that z is greater than 0.22. Now example 3 looks a bit more complicated, but we're really just going to be mushing these two problems together. So we've got z is both greater than negative 1.56, but less than 1.39. So what I like to do with all these problems is just shade what we're trying to find on a normal curve, because that kind of gives you an idea of what we're going to be doing. So we got 0, 1, 2, negative 1, negative 2. Okay, so we have negative 1.56, which is right about there, and 1.39, which is around there. And we want to find all the area in between these two values. So out of these two last examples, we haven't had an example where we have an empty space on both sides of the shaded region. So this is kind of where the tricky part comes in. Because the tables only tell us the area to the left, we're going to have to do some funky math to get in between them. So first, if z is less than 1.39, I'm just going to separate it into these two parts real quick. So we got 2. This is this entire region to the left. And then the z is greater than negative 1.56. We've got 0, negative 1, negative 2, around there. And this tells us the entire area to the right. So if we want to get the area in between them, what we can really do is find this z-score at negative 1.56. So let's kind of wipe this around here. If we find the value at negative 1.56 from the table, and then this is actually less than now. If we find this area and we subtract it from this entire area here, it's going to lop off that end chunk right here and give us the remaining area that we need to find for the rest of the problem. So if we subtract the chunk off of this negative value from the big value over here, we should end up with our final answer with the area in between. So let's do that. Let's find the probability that z is less than negative 1.56. So from the table, we're going to be using the negative z table here. So negative 1.5 all the way over to 6. So we have this 0.05938. 0.05938. And we need the probability that z is less than 1.39, which this will come from the positive table. So we get 1.3 all the way over to 9, just 0.9177. So now, in order to find our final answer, we'll just take these two numbers, the 0.9177, and subtract the 0.05938. And that'll give us something that I can't do in my head quite yet. Negative 0.05938. That gives us 0.85832. And this is the area in between those two z-scores. So when we come into a problem that has a z-score on either side, just find the area of both of them and subtract the smaller one from the bigger one, and that should give you the area in the middle. That's about it. Thank you for watching.